I'd like to now begin technology demonstration number 3 as I continue to explain the important role that technology demonstrations have in the G method. Because we're using independent study and cooperative learning as our primary vehicle by which students absorb massive amounts of knowledge to be able to develop a full multi-game, multi-client, client-server gaming system. That doesn't mean that we walk out of the room after day 1 and come back 14 weeks later and for a demonstration of an amazing piece of software. The fact is that students know where to really begin in order to accomplish such a feat. So an important part of the creativity that the instructor brings to the classroom is to craft demonstrations of technology that he wishes the students to go off and independently research, master, and implement on a week-to-week basis. As I will be revealing in these videos, to do a full multi-game, multi-client, client-server casino gaming system of commercial quality, there's about 8 basic technology demonstrations that the students really have to go through in order to absorb the kind of knowledge that they need to build that kind of complex piece of software. Well, this represents the third of the technology demos. This demonstration has a number of purposes. Even though it's really quite simple, it's a crap game with 2 dice on it. And down in the lower left-hand corner, you'll notice that there's a couple of debug windows identifying the location of the mouse called mouse X and mouse Y. So it's actually quite a simple technology demonstration, but there are a number of issues that the students are going to have to go off and grapple with. In particular, being the third technology demo, this will probably be the first time that they'll actually have to develop a custom class. They will actually begin to put these dices on this panel using a dice class that they'll develop. In the earlier 2 demonstrations, they moved some dice around the table, but they did it predominantly with picture boxes, which is really not an adequate implementation for a commercial quality gaming system. And I also have assumed with this technology demonstration that in the first term they actually did no object-oriented programming whatsoever. So the idea of what a class is, or a constructor, or methods, or fields, etc., would really be unknown to them. So in technology demonstration 3, this is going to be their first attempt to go off and master those concepts on their own using the excellent text that we recommend, as well as using excellent materials including the .NET framework that's on the World Wide Web. So without further ado, let me just demonstrate what some of the things that are important in a gaming system that a student really should be able to master. One of them is in a gaming system, it would be likely that a player will click on different objects and then double-click somewhere else to put those objects on a different place on the gaming table. And that might be, for example, you might want to click on some coins and place them on the different betting locations on the crap table or on a roulette table. So this demonstration is designed to help students master that, where they will click on the die number 4. I've chosen a die rather than a coin, but you can choose any image whatsoever. And it will be recognized, that mouse event will be recognized, and the mouse location will be recognized by the software. The student will have to program all of that, of course, so that the student now knows that he has confidence that where the mouse is. So he will click on die number 4, and then you want him to be able to move the die anywhere else. Here I'll move it into the field, and to double click it, and we'll have the 4 appear on the table. Or perhaps he would move it again over somewhere into the hardways, and he would click again. That would be the kind of functionality a student would eventually have to deploy when he's placing bets on a table. And you'll see ultimately that in final product as students are clicking on $5 coins or $2 chips and moving them around and placing them in different locations. Well, this very early technology demonstration in the course is designed to help them master that. So in particular, to master where is the mouse, recognize the click event on a particular location, in this case the image of the number 4 die, and then to be able to double click and place the mouse somewhere else on the table. It's a very important step forward, again assuming that the students have had no object-oriented design experience or programming experience before CS2 class has begun. The second die is also very important for a variety of reasons. And that in this particular case, what we might want the student to master is to be able to click on an object and then to move or slide the object somewhere else on the image. And in this particular case, we're going to have them do that with the die number 5. So I'd like you to watch very carefully how that happens, because we have some things that we want to discuss as well. So I'm clicking on the die and I'm moving it around the table. You should notice that everything on the table is vibrating, if you will, or flickering as it's known, but we'll just stop there and we'll talk about that in a moment. But again, a little bit different kind of technology challenge for the students. Again, this would be some kind of functionality that he needs on a gaming table to be able to click on objects and slide them around to different locations. Now, technology demonstrations, of course, appear to have some basic functionality, but there are many things, of course, behind the technology demonstration that the instructor or the professor knows that they need to master. In this particular case, the flickering problem is not solved on this particular demonstration, and so the students are challenged to go off and grapple with what that problem is and do enough research to figure out where they can go to find a solution to the flickering problem. This turns out to be a problem that a computer scientist would solve using something called double buffering. And in this particular illustration, since this is happening on the crap table or on this particular location of the form, he has to solve the double buffering problem for what's called the panel, which is taking up the crap table. And of course, the students go off and they solve this problem. It takes them about a week. Some of them do a better job than others. But generally speaking, each team will have mastered this technology in about a 1 week period of time, which is about the time that I like each tech demo to be accomplished, because we have to march along at a very fast pace in order for them to finish 8 technology demos, to do several weeks of quick prototyping in the middle of that process, and then to have at least 5 weeks to do integration of all of their games along with the TCP/IP communication back to the backroom applications that they have to develop in order to talk to a database, trapping player accounting information, as well as doing casino floor management. So this is technology demonstration number 3. Very nice piece of work will be seen by your students. Even if they've had no object-oriented programming experience, they should be able to master this kind of a problem after only being in class about 2 or 3 weeks. Thank you for joining me today.